Hello everyone, welcome to the fourth lesson or introduction to programming. Today we will learn comparing algorithms, block structures, abstractions, and methods. Well, I hope the lesson will be anyway. Anyway, and today let's compare two numbers as an algorithms we learned last time. Which one is better? Let's look at two important things: speed and size. And for speed, let's consider the worst and we need the most guesses. First algorithm might need 63 guesses, but the second one only needs 6 guesses at most. Even in average cases, the first algorithm needs about 32 guesses, while the second only needs about 5. However, there's a small trade-off. The second algorithm needs 2 more variables to work. This shows us that sometimes we need to use a bit more memory to make our program faster. And now let's learn about the basic building blocks of programming. There are three main types of blocks: sequence, selection, and repetition. Repetition. Sequence is simple. When we do things one after another, like following steps in order. Selection is when we make a choice based on condition, like choosing different paths. Repetition is when we repeat something multiple times until a condition is met. These three blocks are like Lego pieces. You can use them to build any program. Uh, the important concept is abstraction. The important concept, a very important concept called abstraction. When we have a big problem, it's often too difficult to solve it at once, so we break it into smaller problems we call the subtasks. Then, if a subtask is still too big, we can break it into even smaller tasks, subtasks, subtasks. Uh, then if subtext still uh, I couldn't say solve the divide and conquer track. We design our solution from top to bottom, and in programming we create a special block of code as a procedure for functions to solve each task. Abstraction tree diagram. The tree. Uh, Here we can see a picture that shows how we break down problems. At the top, we have our main task. Below it, we break into three subtasks: sub, sub, subtask 1, subtask 2, and subtask 3. Some of these subtasks might still be too complex, so we break them down further. For example, subtask 1 is broken into subtask 1a, and subtask 3 is broken into subtask 3a and subtask 3b. The tree structure helps us see how big problems become smaller, manageable pieces. And abstraction benefits. So useful. When we create a procedure, they only need to know what other procedures do, not how they do it. Think of it like using a TV remote. You just need to know what the buttons do, not how they work inside. This makes our code easier to manage because we work with smaller pieces. It's also easier to fix or update our code. If we change how a subcursor works, we don't need to change anything else as long as it does what. And general procedures. When we write procedures, we should make them as general as possible. For example, instead of writing a procedure that only finds the maximum score in the BIL 105E final exam. I couldn't say BIL this test. We should write one that can find the maximum of any array. This way we can use the same procedure for many. We can use the to find the highest exam score, but we could also use it to find the largest true size of basketball players or the highest temperature in a week. One procedure, many uses. And now let's understand parameters. They are very important for making our procedure work with different data. There are two types of parameters we need to think about. First, we have input parameters. This is the data our procedure will work with. For example, if you want to find the maximum, our input will be exam scores or shoe type. Then we have output parameters. This is what our procedure produces. As our example, the output will be the highest score or the largest shoe type. Parameters help our procedures work with data we give them. And, oh, and next. GSID algorithm interaction. Let's look at a new example. Finding the greatest common divisor. Abbreviation is GSID. Of two numbers, the GSID, the largest number that can divide both numbers evenly. Here is how we can break this problem into steps. First, we find all the prime factors of the first number. Second, we find all the prime factors second number. Third, we look for the factors that odd numbers share. Finally, we multiply these common factors to get our GSID. Breaking it down like this makes a complex problems much simpler. Let's see how this works with real numbers. 9,702 and 945. Step 1. We break down 9,702 into its prime factors equals 2 times 3 to the power of 2 times 7 to the power of 2 times 11 is equal 9,702. And 945 equals 3 to the power of 3 times 5 times 7. Step 2, we break down this into the prime factors is equal. Step 3, looking at both numbers, we can see they not share some prime factors. 3 to the power of 2, we take the smaller power, and 7. Step 4, to get our GSID, we multiply these common factors. 3 to the power of 2 times 7 equals 9 times 7 equals 63. So 63 is the greatest common divisor of 9,702 and 945. Next, the final page is a flowchart showing how our GSID program works. We start with our two numbers, 9,702 and 945. The process has three main parts shown in the boxes. First, we factorize the numbers, and we find the common factor. And finally, we complete the GSID. This diagram shows us the main steps without getting into all the small details. That's another great example of abstraction. Each box in the flowchart will be own process. And that's the end of our fourth lesson. In the next lesson, we will learn this algorithm. You can see compare algorithm, input, output, program types, development, error. It will not hard. Maybe we can learn introduction to C language. And see you on the next lesson.